The dawn of a new era, Einstein's general relativity and the 1919 eclipse. In the early 20th century, the world of physics was poised on the brink of a revolution, spearheaded by a man named Albert Einstein. His journey began with the special theory of relativity in 1905, a groundbreaking framework that redefined the understanding of time and space. However, it was his subsequent work on general relativity that would fundamentally change humanity's perception of gravity itself. The equivalence principle, a leap of thought. In 1907, Einstein reached a significant milestone in his quest to comprehend gravity. He proposed the equivalence principle, a concept that would serve as the cornerstone of his new theory. The principle states that an observer in a small, freely falling box, regardless of its position in a gravitational field, would find no evidence of the field's existence. This idea was radical. It suggested that gravity was not merely a force acting at a distance, but a warping of the very fabric of spacetime. In 1911, Einstein began to explore the implications of this principle for light. He posited that a ray of light from a distant star would be bent as it passed close to the Sun due to the Sun's gravitational influence. This was a daring prediction, one that contrasted sharply with the long-held Newtonian view, which treated light as unaffected by gravity. Refinement of the theory. By 1913, Einstein had refined his calculations, employing the Riemann curvature tensor, a mathematical construct capable of describing curved spacetime. He was now able to model gravitation in a more comprehensive way. His theoretical framework matured further, culminating in the completion of his general theory of relativity in the fall of 1915. This revolutionary theory not only addressed the bending of light, but also resolved long-standing puzzles, such as the precession of Mercury's orbit. The point in Mercury's elliptical path closest to the Sun, known as perihelion, had been observed to shift over time, a phenomenon that defied Newtonian predictions. Einstein's equations provided the answer. The curvature of spacetime around the Sun altered Mercury's orbit, explaining this peculiar drift. The 1919 solar eclipse, a moment of truth. The opportunity to test Einstein's revolutionary predictions arrived with the total solar eclipse on May 29, 1919. Eager to observe this celestial event, scientists around the world prepared to capture what could be a monumental moment in scientific history. The British astronomer, Sir Arthur Eddington, led an expedition to the remote island of Príncipe and the town of Sobral in Brazil, equipped with specialized telescopes and a sense of anticipation. As the eclipse unfolded, Eddington and his team meticulously recorded the positions of stars near the obscured Sun. According to Einstein's theory, the light from these stars would be bent around the Sun's massive gravitational field, making them appear in slightly different locations than they would under normal conditions. The results: a scientific revelation. The results of Eddington's observations were nothing short of astonishing. His measurements indicated that the light from the stars did indeed bend in accordance with Einstein's predictions. Eddington's findings, presented to a joint meeting of the Royal Society and the Royal Astronomical Society in London on November 6, 1919, confirmed the validity of general relativity. The news sent shockwaves through the scientific community and beyond. On November 7, 1919, the front page of the Times of London boldly proclaimed, "Revolution in Science, New Theory of the Universe, Newtonian Ideas Overthrown." This was not just a scientific breakthrough. It was a cultural moment that captured the imagination of people worldwide. A legacy redefined. Einstein's work did not merely challenge established scientific norms. It redefined humanity's understanding of the universe. The confirmation of general relativity marked the beginning of a new era in physics, one where the mysteries of gravity could be approached through the lens of geometry and spacetime. rather than through the rigid frameworks of classical mechanics. As the world celebrated this intellectual triumph, Einstein emerged not only as a scientist, but as a cultural icon, a symbol of human curiosity and ingenuity. His theories laid the groundwork for future explorations into the nature of the cosmos, influencing subsequent discoveries in astrophysics and cosmology. The 1919 eclipse and Eddington's validation of Einstein's theory remain a testament to the power of scientific inquiry and the enduring quest for knowledge, reminding us that, at the heart of science, lies the desire to understand the universe we inhabit. Through the lens of general relativity, we were invited to see a universe woven from the fabric of spacetime itself, forever altering our perspective on reality.